Hello MBA students. This video is going to cover using solver and linear programming when you have binary variables. So a binary variable is going to be a variable that either happens or doesn't happen. So it is going to be a 0 or a 1. So it's 0 if you don't do it, it is 1 if you do it. So an example is in the capital budgeting 1 model, which I'm going to show you, and you can either do investment 1 at a $5,000 cost and a net present value of $16,000, or you don't do it. You can't do it partially. You have to either do it or not do it. And so we use zeros and ones in order to work with that type of constraint of either do it or not do it. So in order to do this model, you need to pull up the Capital Budgeting 1 XLSX worksheet. And the first thing we're going to do is identify our decision variables, which our decision variables are going to be these investment levels right here. Now, again, remember that these are going to be binary. So when we put a constraint on them, it is going, in Solver, we are going to have to use a binary constraint on those variables. The next thing we're going to do is calculate the net present value per dollar of investment. So we're going to take the net present value and divide that by the dollars invested. So we see that investment 1, you have a net present value of $3.20 per dollar invested. So we can copy and paste this formula all the way across. Now, if this was not a binary problem, in other words, we could choose to invest at partial levels, and this would be a really easy problem. We would take the highest levels of investments and we would just invest in those until we reached our budget of $15,000. But since we have to choose either all or nothing, the problem becomes a little bit more complicated. So the next thing we have to do is calculate our amount actually invested. So we start that with an equal sign, and we're going to do a sum product. And we're going to do the sum product of the investment levels and the investment cost. Now, the question becomes, why does that work? Well, it works because if an investment level is 0, and say investment 1 is 0, and you multiply that by 5,000, that is a net cost of 0. If we do investment 2, then that's going to be a 1. You multiply 1 times $2,500, and that is going to be $2,500. So what the sum product does with binary is the zeros basically end up as zeros, and then the ones that were ones are then added together. So I hope that makes sense. All right, the next thing we do is we calculate net present value, and we do the same concept. We do our investment levels, and I forgot to put sum product in. Sorry about that. Sum product. There we go. And then we already put array 1 in, which is B10 through H10, and then array 2 is your net present value. Go ahead and hit enter. And your total net present value right now is 0 because there's nothing in these cells, same with the budget. But when we run Solver, you should have data that populates. So next, let's go ahead and run Solver. Go to the data ribbon, go to Solver, and the first thing we want to do is we want to set our objective B17 to a maximum because we want to maximize our net present value. We're going to do that by changing the cells that are investment level cells, and subject to constraints. The first constraint is that the amount invested has to be less than or equal to the budget, and the second constraint is that the investment levels have to be binary. So that is this BIN down here, and go ahead and press OK. And make sure you are on Simplex LP and go to solve. As you can see, Excel returned a solution of $4,600. You are going to invest in investments 1, 2, and 5. You are not going to invest in 3, 4, 6, and 7. So if you were considering a write-up for this problem, which you would tell the managers of the company is that you would recommend investing in 1, 2, and 5, and not investing in 3, 4, 6, and 7. You might even include a discussion because investment 4 that you're leaving off is actually the highest net present value per investment dollar. So you might include a justification for that. And then you would also want to discuss how much you actually ended up investing, which is $14,500, and what your total net present value is expected to be. You then would also want to discuss your solver table. So in this case, you are going to do a one-way solver table that with an input cell of the budget. Okay, and let's look at varying our budget from $15,000 to $25,000 in increments of 1,000. And then for the output cells, you're going to select all of your decision variables plus your total net present value. Go ahead and press OK. And so you can see how first of all, B17 is your total net present value. So you can see how your total net present value would change. So one thing you might want to recommend for your manager is that for an additional $10,000 initial investment, you could increase your total net present value from the project from $46,000 to $77,000. That's a fairly large increase for only an additional $10,000 initial investment. This also tells you, these cells tell you at each level what investments are your top picks if you are going to invest that specific amount of money. So this is a great thing to include in your write-ups and discussions that you would recommend to the management of the company. All right, the next thing that I am going to show you, I'm going to close this out because it's going to create a problem if I don't, is how to do this if you are looking at a multi-year period. And it's almost the exact same thing, just some very minor differences. So first of all, let's identify our decision variables. Life is just a little easier that way. And the next thing we're going to do is we are going to identify the amount invested each year. So this is the same concept. So we're going to do a sum product of the investment levels. And remember, these are going to be binary variables. And then the cost for year 1. Okay. Go ahead and press enter. And then we're going to do almost the same thing for year 2. So go ahead and grab the investment levels, and then you grab the cost for year 2. And then your net present value is sum product. And we're going to grab the investment levels and the total net present value. Okay. And we go back to solver. Solver, and we're already at B18. We're going to set it to a max by changing our decision cells, which is our investment levels. And we're going to have 3 constraints this time. So actually we can put this one in as 1, even though it's 2 separate. So the year 1 has to be under 14,000 for the budget, and year 2 has to be under 4,500. But we can actually put that in at the same time by selecting both of these cells and saying that they have to be less than or equal to this range. And then we can add our investment level cells, which is our decision cells, and put them as a binary. We have to constrain them to be binary. Do OK. And then make sure you're on Simplex LP and go ahead and press solve. So this indicates that your optimal solution would yield a net present value of $44,000, and you would invest in investments 1, 2, and 4. I'm sorry, you would invest in investments 1, 2, and 4 under this scenario. So this is fairly similar to what you were going to do in your problem 40, although you're going to have a 5-year term in that. Again, you're going to do basically the same thing. You're just going to keep adding the years to your constraint calculation. Your net present value calculation should be the same. You're also going to do problem 2. Problem 2 is going to add a little bit of complication in that you are going to calculate the net present value yourself in that problem. So you have the information that you're going to need to do that in your file given, which is P06-02 that you'll need to download. As always, if you have any questions, you are welcome to call or email me. I'm always happy to help you through the problems if you're struggling. Hope you have a great day.